So when we have our average and we have our range and we have our quartiles, that's giving us more information about the data. Just having an average doesn't give us all the information, and just having the range, so there's more statistical stuff that we need to look at that really tells us more information about the data. And one of the most important things for statistics is variance and standard deviation. The variance is a way to look at all your data and figure out how spread out it is. Mathematically, it is the arithmetic mean of the squared differences between each value and the mean value. We're going to look at what that means in a bit. For the most part, we're going to do this with our calculator. And then your standard deviation is just a square root of your variance. So I would like you to enter, let's do this half of the class, enter in test 1, and this half of the class, enter in test 2 into your calculators, into list 1, and then you can calculate the mean, the standard deviation. Well, not the standard deviation yet, but we'll look at all those quartiles and things like that, and we'll look at what's the difference in this two sets of data. Are those the values that you were able to get? And if you look at your statistics, you can use the min and the maximum, or it's not hard to figure out the range because it goes from 5 to 20 here and 10 to 16 there. So this is a good example because here we have two sets of data, and when you look at the mean, they're identical. You look at the mode, they're identical. You look at the median, they're identical. So all of our measures of average come out to the same thing, but the data is quite different. If these were test scores, this test 1 has some people that did really poorly and some people that did really well. Whereas test 2, everybody was closer. There was nobody that did really poor, but there was also nobody that did really well. So we need a way to say, how can we describe these two data sets besides just saying something about the range? Because, for example, you could have the range where I change this first number to a 6 and this last number to a 20, and still my data will all be the same, and my range will even be the same, almost. So not only could I have all of these things the same, so we need to find something else that helps us tell us which data is more spread out and which data is more compact. So here are the frequency tables for each test, and we talked about that the marks vary more on this first test than they do on the second test. So we'll be able to look at how we can measure that data, how it varies, with the variance and the standard deviation. So mathematically, if you wanted to do variance and standard deviation the long way, this is what you would all have to do. And one of the things you'll find is when you look at your calculator, when you did 1var stats, a lot of this information is in there. But here we have all our marks for our first test and all our frequencies. And this third column, fx, is just your frequency times your mark. So 5 times 1, 6 times 1, 7 times 2. And those are all listed there and added up to 416. Remember what that stands for? That's the symbol for the mean. So if you figure out what your mean is, and how would you figure out your mean by hand? Well, we've got 416 is what they all add up to. Divide by 32, and that would be your mean. If we do that on our calculator, 416 divided by 32, Well, we already had it from before. We knew it was 13. Does it make sense that 5 is 8 below 13? And this one's 7 below, 6 below, 5 below. 13 is right on the mean. So these are all our different spreads from how far away they are from the mean. So what we do for standard deviation is we take the spread and we square it. Because being 8 below is the same distance as being 8 above, and when you square it, they all become positive numbers. So it gives us all values that are positive. And then if you take all of those ones and multiply by your frequency, so here's your frequency, how many times that one happened. So for 7, it happens 2 times. 2 times 36 is 72. And take all of those values and add them up, we'd get 616. So from this, we can check our mean, which we did already. 416 divided by 32 is 13. Now our variance is that 6th column, its total, divided by how many items we have, which is 32. 616 divided by 32, we would say that our variance is 19.25. The standard deviation, which is the symbol sigma, we find by doing the square root. And the square root of 19.25 is approximately 4.39. Take out your formula sheets. Is this formula on your formula sheets? So this formula isn't on your formula sheet. That's because it's very tedious to calculate by hand. So you're not going to be asked to calculate it by hand, but it's important to know where it comes from. Some of your university classes might get you to calculate it by hand if you take a university stats class. But just to understand what this means. So here's the formula. Sigma is the square root, which is what we did at the end here when we did the square root of 19.25. The inside here is just adding up all of our frequencies. So take a frequency multiplied by how far it is away from the mean squared to get that value, and then adding all of those up. So when we look at this formula, that's why there's a sum there. You're going to add them all up. Each frequency times by how far each one of those values was from the mean squared. So we used our calculator to verify the standard deviation for test 1. So those of you that did test 1, can you find the sigma on your data there? And did it match? Did it match with the 4.39 that we calculated? Yes, good. And for those of you that did test 2, did you get your sigma for test 2 to be 1.77? Good. Now, we're mainly going to be using sigma. And on our calculator, we have 2 standard deviations. The sigma one is the population standard deviation. So we will always use that. Once you get into university and you're looking at some more of the fine details of different standard deviations, sometimes you'll look at sample standard deviation. It's exactly the same, but instead of dividing by n items, you divide by n minus 1. So if you do take a lot of stats in university, you're going to find out why is it that you divide by n minus 1 instead of n, and why that makes a sample standard deviation instead of a population standard deviation.